combination of limit. Who can stand up, close the eye and say it?
Close your eye and say it.
Who want to do that? Okay, stand up and close your eye and say it.
Fx plus h minus fx over h.
Very good. A round of applause for him, yeah. He at least did part of it right. Okay. This is algebra, this is calculus. So algebra, calculus. Okay. This is algebra, this is calculus, this is something we know, this is something we do not know. This is slope of line. This is slope of. This is slope of line. We call it m. This is slope of curve. We call it derivative. We call it derivative. I should write it very nicely because derivative is the word that scare everyone. Derivative. Okay. We can call it d because this is m. We can call it d. Nothing wrong with that. What do we call this one? Talk about it. X. Then why should we call this one? X. It's always an independent variable. What do we call this one? Y. Then what should we call this one? Y. Okay. So far everything is same. So far everything is same. Okay. Then what are you going to call this one? We did call it before. X1. What are you going to call then this one? X1. We're going to call it X. Okay. Things will be a little different. You're going to call it X. You're going to call it X. Instead of X1, you're going to call it X. What are you going to call this one? What are you going to call this one? Y1. What are you going to call this guy?
Y.
Good guess, but not good enough. Instead of Y, what can we call? What can we call? No. Can you write? Yesterday you wrote 4 by not writing 4. 2 square, right?
X squared.
Oh, wait.
Y. X. Y.
No.
X squared.
No. 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 No.
X squared.
No. No. No.
Right?
F of X.
Oh, damn function.
F of X.
But we know F is Y.
Yeah, that's the same.
That's right. I gave you a hint.
Write 4 without writing 4.
Okay, so F of X. Is that okay? Oh, here? Yes. What is this one? You saw it before. X2. If this one is X2, what is this one?
X1. Oh, X2.
X plus H. Okay. X plus H. Pretty soon you're going to explain that. Pretty soon.
Please.
Pretty soon. But what is this one then?
X2. Y2.
Y2. What is this one then?
G of X.
F of X plus H. Who's that? Okay, very good. Okay. That was the reason we use this one instead of Y. If we write Y and we write F of X plus H, then they don't look same. We try to make them look as same as possible. Sometimes that's not easy, but sometimes it is. At least you can try. Okay. Now, this is a damn line. You saw that before, right? This is just a line. And what do you call that line? Y equal to X, right? The degree is 1. The degree is 1. Okay. And there are 2 points in the line, right? There are 2 points in the line, right? Okay, great. Now, this is not a line. This is y equal to, someone gave me, y equal to x squared. Y equal to x squared look like a parabola, right? Okay. So this is the right side of the parabola. Okay, this is the right side of the parabola. Try to draw nicely. Here is one point, and here is another. Here is another point. I'm gonna make a card look like they touch both one. Okay, if they don't touch it, then I will shift it. I'll shift it in a way that they'll touch it. Okay. So here x plus h. Now I'm gonna explain. Okay. Before I explain, let's derive that machine again, and we're gonna derive it here. Here we're gonna call it slope of line. We're gonna write m, and here we're not gonna call m. We're gonna call d derivative. And instead of d, we're gonna write f prime of x. F prime of x. I just want to make it right here m. Okay, so you see that, right? Here we call it m, here we call it f prime of x. Different name, and that name's associated to derivative. This name associated to slope of line. This is slope of curve, and this is slope of line. y2 minus y1. Then that's supposed to be what? What is our y2?
fx plus h.
Very good. Plus or minus?
Minus fx. No.
Very good. That's it. That's it. Yeah, you did nothing wrong. You did nothing wrong.
I'm scared.
Yeah. What are you gonna write here?
X plus x.
x2 minus x1. Then get
X minus x plus x. Plus h.
x plus h minus x. X. Can you cancel them?
No.
Why not? Cancel. So you can write. Can you write f of x is equal to f? Tell me. Right? Read.
Okay. F of x plus h.
X plus h minus f.
Okay. This is almost the definition of derivative. The best creation of human mind. Almost. Did I say almost? Almost. How can we make it? How can we? Where should we add the missing part? Where should we add the missing part?
Wait.
This is the equation for the. This is the slope for the line. This is the slope of the curve. But something is missing. A tiny, a little bit thing is missing.
You have two variable h and x. Maybe you should try to find one variable that you want to put in.
Yeah.
Did you want to understand?
All right.
You're looking for this.
I'll give you enough food for thought. I will give you enough food for thought. Explain that. Now I'm going to write the scenario number 2, and this is this one. Scenario number 2. This is x. This is x plus h. This is f of x, and this is. You tell me. This is what?
F of x plus h. Oh, that.
This is f of x plus h, and there is a line there, that, and then that, this is that, this is x1, this is y1, this is y1, this is y2. Alright, if x1 is 10, can y2, if x1 is 10, can x2 be 20?
Yeah.
Can x2 be 20 million?
Yeah.
Can x2 be 20 billion?
Yeah.
Okay. There is no limit. There is no limit. Very good. So if x is 1, x2 can be 10. Or x2 can be 100. Or x2 can be 1,000. Or x2 can be 1,000,000. Or x2 can be 1,000,000,000,000. Does that make sense? There is no limit. Okay. Get that point? It can go as big as possible. If x is 1, then what is this x? 1 plus h. Now, 1 plus h is a number, right? How big the h can be?
No limit.
How big the h can be? Not even close.
What?
How big the h can be?
Limitless. Limit.
Small. Come to small. No.
Very small.
Very small. Give me a small number. 0.0. Oh, that's not within my video. 0.001. No, that's not a small number.
So it's infinitesimally small.
Infinitesimally small. I like that word. Infinitesimally small. Give me an infinitesimally small number.
1 to the minus 20. 0 point infinity.
1 to the negative 10, 12 power.
Okay, that's infinitesimally small. Can it be more small? Can it be smaller? So 0, 0, 0, 1, 0.00001, 0.00001, 0.00001. So it's always possible to make it smaller. See? This is smaller, even small. It's possible to make it smaller. If you do make it smaller, it approaches to what?
Negative.
No, it doesn't approach to. It approaches to 0. It approaches. H approaches to 0. Okay, so that very good. H approaches to 0. That means H approaches to 0. Very good. So where then what should the 1 be? If this is 1, what should this one be?
1 plus.
Which one is better? 1 plus 0.000000001 or 1 plus 0.000000001? Which one is better? The one on the bottom is better, because the one on the bottom is the smaller. The smaller it is, the smaller you can go, the better it is, the better answer you can get when you try to solve Mr. Bari, Professor Bari break the law or not. If you are a cop, I'm going to make all of you a cop, and I'm going to be a driver. So I'm going to driving a car, and you are a cop, you think that I'm driving faster than the speed limit. You're going to use the calculus to verify, to investigate whether you should give me a ticket or not. Okay, then that means this will give you more precise information than this one. Does that make sense? Okay, great. So what are you going to write? What statement should we add? You're going to come back to here. What statement is missing here? Limit. Okay, so we're going to remove that. You're going to write f prime of x is equal to limit. And then what? As h goes to 0. As h approaches to 0. And ladies and gentlemen, this is the definition of limit. And this is the biggest human creation. It looks nothing, but it gives us everything. So you should memorize it and memorize it until you completely memorize it. You're gonna write it down every day a few times. Okay, because this is like something that how many of you memorize Shakespeare poetry? This is more important.
This is a line of curve. I mean, slope of curve.
Yes, and derivative. This is the definition of derivative. If you ask you to write down the definition of derivative, you should be able to do it in a fraction of a second. I'll never ask you to derive it, to prove it, to show everything now. Okay. Now, we're going to find the slope, and then we're going to find the equation of the line, and then I'm going to give you the challenge. You all going to get a job tonight. You are a cop, and I am the driver, and you're going to find whether I break the law or not. Okay, so let's give you the background, enough background to do your job. Well, before you get the job, they give you training, right? Without the training, how are you going to kind of down the crime? So I'll give you training so that you can investigate. Okay.
You keep recording?
Yeah. Okay. So y is equal to, what is our function? Y is equal to x squared, right? Y is equal to x squared. Now we're going to write the definition of limit. What is the definition of limit? Who can stand up, close the eye and say it?
Close your eyes and say it.
Who want to do that? Okay, you stand up and close your eye and say it.
Fx plus h minus fx over h.
Very good. A round of applause for him, yeah. He at least did part of it right. Okay. No, you did a good job. This part you said it correctly, right? Okay. What are you going to do now? You're going to put this in action. So you're going to write f prime of x is equal to limit the h approaches 0. Now you see x, right? X is a variable. What is variable? Variable is something that is waiting to be replaced. Variable is something that is waiting to be replaced. And replaced by what? X plus h. Replaced by x plus h. So x plus h square. Does that make sense? Okay, now what should I write? What do you see?
X squared minus.
Minus. Okay, minus. F of x. What is f of x?
Y.
Y. And what is y?
X squared.
Very good. Wow. Great. And what should I do?
Over h.
Over 8. Okay, that's it. I mean, we did the hard part. Now is algebra. Nothing calculus from here on. Everything is algebra. We done the calculus. This is calculus class, but what percent of the calculus are you going to do? Every problem I give you, what percent of the calculus in the problem? Like 10% of the calculus and everything else is algebra. Okay, so everything else is algebra. What are you going to do now? F prime of x is equal to limit as h goes to 0. Yesterday you told me a plus b squared, so you should be able to tell me today.
A squared x squared plus 2x plus h squared.
Very good. Very good. That's very important formula and we all should memorize it. Over h. F prime of x is equal to limit as h goes to 0. What are you going to do now? Something cancel.
Yes.
X square and x square cancel. And you have to factor out something. What are you going to factor out? H. And if you factor out h, yeah, walk me through.
2x plus 1.
2x plus 1 over h. H is cancelled. Can you do this? Oh, yeah. Okay, very good. Okay, everything is good. F prime of x is equal to limit as h goes to 0, 2x plus h. Okay, now h goes to 0. That's what we've been talking about last few seconds, right? So let h goes to 0. Is that bothering you? H goes to 0 because h is so small, infinitesimally small. Someone mentioned that fancy word, infinitesimally small. So h goes to 0.
The thing that confused me is that h is not an exact number. It's just a bunch of numbers close to 0. That's the thing that get me confused. H is not a specific number.
So main challenge is you have to algebraically isolate h and cancel the h on the bottom. Once you cancel the h on the bottom, you good. And the h on the top, you always approach to
0.
h on the top always approach to what? 0. So f prime of x is what? Tell me now.
It's 2x. So professor, f prime of x of 2x to the third could be 6x squared, right?
Yes. But we are not doing that. We are not doing power rule. That's like 2 months from today. We are not doing it easily. Okay. F prime of x is what? Tell me what is the next line I should write.
2x.
2x plus.
Why should not I write limit anymore? Very good. So that part makes sense? Very good. That logic. I already let the h goes to 0. I should not write limit anymore because limit part is over.
You actually cross it out because you said the h goes to 0, so you cross out the h and leave it.
Yeah. So I no longer need to write limit. Does that make sense? Because limit part is over, calculus part is over. 2x. How many slopes exist in this line? In this line, how many slopes exist? Yes. Infinitely many. There is a slope here, there is a slope here, there is a slope here. As many slope as you like, you can find. Now, what and where we try to find the slope? What point? When x is 2. So how do we find it? Okay. And then what do you get? 4. So what is our 2 point? 2 point make a line. What are the 2 point?
2.
2, 2 comma 4. Now we're gonna draw the equation. Well, not the equation. We're gonna draw the graph. So this is y equal to x squared. So this is 2. There is a point here. We call it what? What do you call this one? Slope of a tangent line. So what is the slope of a tangent line? 2x is the slope of a tangent line. Does that make sense? What is the slope of this one? What is the difference between the slope of here and slope of over there? How many slope exist of this line? 1. So we found the slope. Okay, what is the slope here?
1.
And what is the slope here?
1.
And what is the slope here?
1.
1. So slope 1. It never changes. How many slope over here? As we said, many. Infinite. How many slope at point when x is 2? How many slope? At point 2, how many?
1.
Just 1. Does that make sense to everyone? Okay, great. We're going to find the equation of the line. How can we find the equation of the line? Same formula. Y is equal to mx. What?
No.
M x minus x1 plus y1. Okay. This part you're going to do at home and you're going to show me on Monday. Now I'm going to give you the challenge.
That's the equation of the tangent, right?
Equation of the line. Equation of the line. This is the slope of the tangent. This is equation of the line. This equation of this guy. Equation of this guy. Does that make sense? This is line. This is curve. However, this one is line. How many tangent line you can draw?
1. At this point.
So how many equation of the line you can have? As many line as you can do.
As many lines you can do tangents.
Yeah.
Okay.
Alright. So I'm going to give you the challenge. How much time we have?
A lot.
Okay.
Yeah, a lot of
Can someone answer why no?
Because the tangent at every junction is going to be different.
Everything. Okay. So how many slope you can have from something that look like y equal to ax plus b? How many slope?
1.
1. Just one slope. 1. Y equal to ax squared plus bx plus c. How many? Infinite. Does that make sense? This is what we call this one. A linear function. This is what we call that. A quadratic function. Linear is the line, look like this, and quadratic is the parabola, look like this.
Find the slope of a specific point.
Right, a specific point. A specific point. There are many points. At each and every point you can write a line using the slope of a curve, or using the, what is the name of slope of a curve? Derivative. Okay. Let me write that. Very important problem, because I train you to be cop. Now that you are cop, your job is to investigate, and my job is to drive fast because I have to get my class on time. Okay, so this is the problem. So write it down. Professor Bari went out for 1.5 hour long bike trip and his position function is P of t is equal to 40 over 3 t squared in 20 miles of the trip. He saw a speed limit sign. (25 miles per hour).
Professor, what is that? You have this position function. What is the abbreviation you have after?
Say again.
After
40
after
over 3.
No, after function. Yeah, this.
P of t.
Oh, P of t.
P of t, like f of x.
Yeah, okay.
This is P of t. This is like physics.
That is 40 over 3 times 2 squared.
T for time. T. So position is a function of time. Position is a function of time. Did Professor Bari break the law? I want you to first, so this will make your transition from algebra to calculus even smoother. Okay. You're gonna make a transition to calculus by hugging the algebra. So number 1, diagram. Number 2, graph. Number 3, all the missing points. Number 4, show why algebra cannot, when algebra break down. So show when algebra break down. Algebra can solve this problem. Show when algebra breakdown. Again, for example, Einstein, Newtonian mechanics, Sir Isaac Newton law break down when things approaches the speed of light. Einstein physics break down when you go close to black hole. So everything has a limit. Algebra 2 has a limit. Algebra break down when you approach to zero. When you add to 0, algebra breakdown. Show me that, and then use the calculus, your background, to make at least a hypothesis whether I broke the law or not. Okay, I give you 5 minutes. Break the law. Innocent. I break the law. How many people think I broke the law? Raise hand. 1, 2, 3, 4, 5, 6. Okay, this 6 people. You guys are very bad. You think I broke the law, right? And remaining people, think that I did not break the law. I'm innocent. How many remaining? Like 20, 25, 25. Okay. All right. How many people clueless? Okay, clueless. Raise hand. Oh, clueless. 1, 2, 3, 4, 5, 6, 7 people. 8 people are clueless. So 8, 14, and then maybe 16 people think I am innocent. Okay. All right. So, all right. These people are losers. Yeah, I'm not innocent. Yeah, I actually broke the law. Okay, let's see. Let's first do the diagram. Okay. The first thing.
Range.
Time. Okay. Time initial. So what is time initial? 0. Okay. Then what should the time final be? 3 over 2. What is D initial? 0. What is D final?
20 plus.
We don't know. What is this? This is, what is the D2? What is D2? 20. What is T2? We don't know. Okay? We have to find. Can we imagine a point here? Yeah, there are points everywhere, right? We can imagine a point everywhere, right? We can make a small interval here, can we?
Yes.
Alright, we'll come back to this one. This is the diagram. If I am, this is my bike. If I start my journey over here, then can I move faster than 25 over here?
No.
Yes, I'm free to do whatever I want to do. Am I free to do whatever I want to do here? Yes. Here?
Yes.
Here?
Yes.
What about here?
No.
Yes, everything. I am free to do whatever I need, I want over here. Nobody cares, right? Because there is no speed limit sign. If there is no speed limit sign, no cop can pull you over. Does that make sense? Am I free to do anything bad, anything more than 25 over here?
No.
I'm taking a chance. I'm taking a big risk. Okay. So this is our point of interest, right? So this is our 0 over here, our point of interest. So when we find T2, and that is a big deal. That is a big deal. Why? Because we want to find whether I broke the law right here. Not here, not here, not here, not here. Right exactly here. Does that make sense? So this is our point of interest, and we're going to pay special attention to that point. Now we're going to draw a graph. Diagram and graph, two different things. Diagram is the geometric version of the problem, and graph is what? Graph is the algebra. So graph, what is this one? The time. The time is in hour. What is this one? Position is in?
Position.
Is in? Mile. In this problem, it is mile, right? Mile per hour, it is mile.
Yeah, that's what I was asking you. We came in with the function.
Oh, okay, that's what you asked me. What unit? Okay.
What unit? That's what I was trying to get.
Okay.
Yeah.
Okay, fine. I thought you asked me what unit should you write here. We don't have to write hour here.
Right.
We don't have to do anything, any other thing. Okay, great.
They can be swapped. What you just did. Can the man go on the X and the time on the Y?
No, it is convention that the independent variable is the time and the dependent variable is the
Okay.
position.
All right.
This is convention. We're not going to change convention. What is the next thing to do? Scale it. What is this one? 0.5. What is this one? 1. What is this one? 1.5. What is this one? 10, 20, 30. You stop at 30 because maybe 40, I don't know, maybe 40. We'll see. We'll see what is our D final. We don't know yet. Okay, let's find our D final. Let's find it here. This is our graph, but not complete. We will complete it soon. That is our diagram, not complete. We will complete it soon. Lots of missing thing. Algebra will allow us to find the missing variable. Does that make sense? Okay, now let's find those. Step 1 is going to be like 50 steps. So, step 1, find what? Find the missing, find the F. So, find the F. Finding the F. Can someone tell me how to find the F?
Take the time, final time, you plug in the equation.
Very good. Just tell me, use the position function. That's it. Position function is P of t is equal to 40 over 3 t squared. What is time? 3 over 2, 40 over 3, 3 over 2 squared. 40 over 3. Is it 30?
Yeah.
Okay. Can you write 30 over here?
Yeah.
Okay. Pay very close attention. I'm trying to make it fun because so that you pay more attention. Now, what is the next thing you're going to find? T2. So step 2, finding T2. find T2? How can we find T2?
T1 minus T0 minus
20, so you plug in.
T5.
Use the function. Okay. P of t is equal to 40 over 3 t squared. All right. What is our P of t? In order to find okay. What is our P of t?
1.5 or 3 over 2.
Now, what is our P of t? What is our P of t, guys? No, 25. Very good. Very good. A round of applause for him. Very good. Very good. All right. Do you need any other explanation why it is 20? Because at 20, you are trying to find the time. At 20, when it is 20 miles, you want to find the distance. You know the distance. Now you want to find the time. When the distance is 20, you want to find the time. Not 19, not 21. You want to find the time when the distance is 20. So should you replace it by 20 or should you replace by something else? What do you replace it by? By 20, right? Does that make sense? Okay, so 20 is equal to 40 over 3t squared. Everything else is now easy. So multiply this one by 3 over 40 and 3 over 40. 40, 40 cancel, 3, 3 cancel. T squared is 60 over 40, 0, 0 cancel, 2, 3. So t squared is, am I going fast? T squared is 3 over 2. So t is square root of 3 over 2 and t is 1.22. H should approach to 0 or H should approach to 1.22. H should approach to 1.2 because the curve you are looking at 1.22. You don't look at any other time. You know that I was moving from 0 hour to 1.5 hour, right? Right? So should you look at 0 hour, 0.5 hour, 1 hour, 1.5 hour, or 1.22? 1.22. You have many choices. 0, 0.1, 0.2, blah 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 blah, 0.5, 1, 1.22, 1.5.
So the limit is approaching 1.5.
No. Where should you? What is your point of interest? There are lots of time between 0 to 3 over 2. There are a lot of time between 0 to 3 over 2. What specific time you should look at? 1.22, right? Why? Because that's where the speed limit sign, not before, not after. Does that make sense? Okay. So 1.22. Where should I write 1.22 here? Because at 1.22, there is a speed limit sign, right? So you can write T2, D2 is what? 1.22, 20. That's what you look at, right? Does that part make sense? Because that's going to come back when you do the algebra calculus. Does make sense to everyone? Why you raise hand if you have no clue why we have to use 1.22 as a point of interest? You have no clue. Who have a clue? Raise hand. People with clue, help the people with no clue. Yes.
Because the distance he is at that point is 20. So that's a critical point. So you need to know the time at that particular point.
And at 1.22, that's the point of the 25 miles, so that's the point that you have to look at. Anything before, anything after doesn't matter.
If I change, this is 21, then would it be 1.22?
No.
Very good. If I change it to 19, would it be 1.22? Would it be any other number? Yes.
Yes.
But it would not be 1.22. That makes sense? Okay. So I'm going to go back because I'll give you probably a project to do that. Yeah. Okay.
20.
Oh, 20? Okay.
It's because the speed limit sign is at 20 miles. If it was like 21 25, the speed limit is, the plus sign was there, then you're gonna consider the same, right? So why are we our reflection is based on 20 miles, not because we saw the sign and we are not supposed to go over.
That's right. That is right. Because at 20 miles there is a speed limit sign. Not 21, not 19, not 15. If it was at 15, then what that would be? You put 15 here, right? And you find the time, and that would be your point of interest. Then the age approaches to that number. Does that make sense to everyone? Yes.
The other thing why you put 3 over 40 instead of the other one? That's the only thing that confused me.
3 over what?
3 over 40.
Oh, okay. That's the algebra. So I want to isolate. Who want to explain that? I want to isolate T. Okay, explain it.
I'm still trying to catch up on the notes, so I'm going to hold off. But I understand that you want to isolate T fully, so that you'll be able to get that specific time interval.
You're looking for T.
What you did was it looked like you flipped it so that you could cross multiply.
So if I multiply this side by 3 over 40, can I multiply this side by 3 over 40?
Yes.
All right. So they are the same. Why 3 over 40? Why not something else? Because 3 over 40 isolate T. Right? You completely have to isolate T, right?
Okay, to cancel that one, you just flip it
Yeah.
on both sides.
Yeah.
No.
Okay. Can we move?
Yeah.
Okay. Now that we know our point, or at least enough point, we're gonna cross that 40 because the last is the final destination is 30, so we don't need 40. Okay, great. So what are we gonna do? We know that y equal to x squared is a parabola. The right side of the parabola, not the left side, because the left side you cannot, because in physics there is no left side, not yet. Yes.
So now what we will remain as it approaches.
Not yet. We are not done with algebra. Not yet. The algebra, first we'll do algebra. So the algebra is to find the velocity, which is speed. You feel comfortable calling it velocity? What is velocity? Velocity and speed is the same thing. Should we call it speed or should we call it velocity? Velocity? So velocity and speed is the same thing. No. Distance over time, that is acceleration. That is something else. Okay. Acceleration is something else. Velocity, the speed and velocity is the difference between speed and velocity. Speed is a scalar quantity, velocity is a vector. Speed gives you one information, how fast you're moving. Velocity gives you two information, how fast you're moving and direction. This time, Professor Bari is moving to the east. Does that make sense? So the direction is given and the speed is given. So it's vector quantity, and so we can call it velocity. But if you call it speed, fine, because we're not gonna do any physics here. Okay. Now what are you gonna do? At 1.5, what happened? At 1.5, look at 1.5 and 30, right? This is a point, right? Does that make sense to everyone? Now you're going to put a ruler and you're going to draw a line. Does that make sense to everyone? You're going to find the slope of that line. Would that be algebra or calculus? Algebra. What do you call these two lines? I want to do a good job because I'm recording it. Okay. You see the line? What do you call this line? Y equal to x squared. Is this the line y equal to x squared? This is a quiz. Is this the line y equal to x squared or the curve y equal to x squared? Very good. So we are on the right direction then. Okay. Then what is then the slope of this line?
Mx plus c.
We're gonna find it. We're gonna find it. So we're gonna find it. The slope is what? Velocity. So velocity is what? Who said distance over time? Someone said distance over time, right? Yeah. Okay, very good. So it's the same thing. Y2, Y1, X2, X1. So distance over time means d final minus d initial and t final minus t initial. What is d final? D final is 30. What is d initial?
20.
What? 0. Come back to diagram if it doesn't make sense. D final is 30 and d initial is t final is 1.3 over 2 and d initial is t initial is 0. That part makes sense? So then 30 times you flip them 2 over 3. So 3 goes to 30. So 20. How fast Professor Bari was moving? What is the velocity? 20. So those people who said that, those cops, 30 cops here, some cops said, I broke the law. But I was moving 20 miles per hour. How did I break the law? I wasn't breaking the law. So those 7 people who said I was innocent, those people are correct, right? But I call them losers. Why did I do that? Okay, I put you in a big problem now. So why did I call them the loser if the algebra problem answer shows that they are indeed correct?
Because there's the point when algebra broke.
Not yet, yes.
That's because maybe after 21 or 22 you're going faster than 25 miles per hour. Because we only know the time, the speed at that time. We don't know the speed after.
Very close, but not the precise answer. Very close. Yes.
Maybe somewhere in between you was going between.
Very close, but use the vocabulary that I'm looking for. Yes. Yes. If you are a cop.
It's a speed zone.
If you are yes.
It shows the slope of a parabola. It wasn't the slope of a line.
Okay.
Wait, at this point, after the 25, maybe.
You are not thinking easy. You are thinking something like you have to thinking calculus somehow, right? No, not yet. Think algebraically.
Do we have to show when the algebra is breaking down?
No, tell me why. If you are a cop, this is not the number you look for, and why? Why not? This is the number you look for.
Because that's an instantaneous.
Oh, because this is at 1.2
instantaneous velocity.
Okay, so you are using very difficult vocab, but not the easy one. Okay, what is the other one? There is the instantaneous velocity. Calculus will give you that one. That's right. So if this is not instantaneous velocity, what is this? The average. That's the one I was trying to. I was hoping you to say that. This is not instantaneous velocity. Instantaneous velocity is calculus. This is not instantaneous velocity. This is average velocity. Now you tell me, what is the difference between average velocity and instantaneous velocity?
So instantaneous velocity gives you the for a specific time point. Average is whole trip.
Very good. Very good. A round of applause for him. Very good. Very good. The average velocity is nothing. Average velocity is probably from where he was sleeping over here, taking nap, whatever, we don't know, and moving very fast over here. Average velocity is the total velocity. If you are a cop, you don't care about the total velocity. You even don't care about what he was doing over here. You care about what is happening right here, right at that moment. In fact, you care about only when D2 and T2. You care about what is going on at D2 and at T2 and D2, or 1.22 comma 20. Does that make sense? That's what you care about. You have to find what is going on at 1.22 comma 1.22 comma 20. You have to find that. This is not what that is. This is the average. Does that make sense? So we're gonna write 20 over here, but that's not what it is. That's the second line. We're gonna write, this is the velocity, slope of the second line. Write it down. I'll take your question in a second. Slope of second line. secant line. This is the slope of secant line. Are we interested to find slope of secant line? No. We want to find the slope of tangent line. And the slope of tangent line touches one point. And what is that one point? 1.22 comma 20. Does that making sense now? Okay. Okay.
So it'll always be the average if the initial and T initial start at 0. That'll always give you the average as opposed to having an actual figure.
Every journey has average. Every journey has average and every journey has instantaneous. How many average in every journey?
Multiple. Oh, one average.
One average. How many instantaneous in every journey? Infinite, depending on what time you're talking about.
So it requires a T1. I mean a T2.
T2 and D2. Yes.
Okay, that's what. It is.
So you have to approach what? You have to approach the secant line. So now I'm going to give you the most beautiful and most important line of calculus 1. When secant line, when h approaches to 0, when h you write it down. You write it down. You write it down on above the content. Above the content, because this is the most important line of calculus. When secant line, when h approaches 0, in this case, what is h? Let's write first h. When h approaches 0, because h is default. H is default, but this is physics problem. Instead of h is going to be delta t. When h approaches 0, secant line, slope of secant line converts to slope of secant line converts to slope of tangent line. Converts to, if h approaches 0, in this case delta t approaches to not 0, delta t approaches to, because this is default. This is a default definition. Does that make sense? In this case, we're not going to use h, we are using delta t. Delta t, we're not going to use 0, we are using 1.22. So delta t approaches to 1.22. Then secant line converges to tangent line. What is secant line? Secant line is, what is secant line? Secant line is d final minus d initial, t final minus t initial, converts to, what is the tangent line? D t2 comma d2. When h approaches to 0, secant line converts to tangent line. Does that make sense? Lots of technical things. People usually never understand it without spending like 2 years. You spend like a few hours. Does that make little bit sense? Okay, good. Okay, great. Alright, so this is not what we're looking for. Then how can we say that when secant line approaches to, when h approaches to 0, this case t approaches to 1.22. Can we make a point here? We talked about before, right? Then this average is better than this average, right? Is this average better than this average? Right? Because this point is closer to over here. So if he was moving very fast over here, the probability of him moving fast over here is very high. So let's say T1. If this is 1.22, can this be 1.23? No. 1.23 is here. What can this one be? 1.21, right? Or it can be 1.20. It can be 1.19. It can be 1.1. It can be 1.
1.1.
Great. So let's call it 1 because 1 make everything easy. Calculation easy. Let's call this one D2 is what? How can we find D2?
You just Prof
You tell me use function. Okay. So P of t is equal to 40 over 3 t squared. We want to make our life easy. So 40 over 3. 13 point what? I remember you saying 13 point something.
3.
Why did you say 13.3 like an hour ago?
Yeah.
This was the reason you said that? No.
I use it both to calculate for any time and then to make
Okay. That was a coincidence. 13.3. 13.3. Where do we write 13.3? Okay. Right. So please pay attention.
That's D1, right?
This is D1. Thank you. He's paying attention. Okay.
I have to.
By mistake I wrote D2. How can you have two D2? No. This is D1. This must be D1. Okay. Now we said that we claim that as delta t goes to 1.22, secant line converts to tangent line. If that is true, then this velocity and this velocity would be different. You think? Yes, it will be different. In fact, this velocity is, if this velocity is lower, then I probably did not break the law. If this velocity is higher than this one, I probably did break the law. But no way you can say I broke the law, because this is still algebra. This is still secant line. This is still secant line, but smaller interval. Does that make sense? Okay, so let's do that. Which one should I erase? Yeah. Okay. Now what we're gonna do now? We're gonna find the velocity of smaller interval. Secant line, smaller secant line, small secant line. The small secant line will be what? It will be this 2 point. This 2 point. Let's draw this 2 point here.
Professor, before you continue, you have two D1 and T1.
No, forget about the zero. That's the initial number. That's the initial one.
It's a TI.
It's a TI.
Oh, okay, TI. Okay.
TI.
That's the initial one. Forget about it.
Good?
Okay.
Okay. So this was the initial graph. This was the initial graph. Y equal to x square, right? Please understand the graph, because the calculus is graph. So this one was 30. This one was 1.5. So far so good. This one was 1. This one was 1. This one was 0.5. Okay, so this one was 10. This one was 20. Now the first one is 0, 0, and this one is 1.5, 30. And we found the velocity of that one. Does that make sense? Now we are trying to use our algebra skill, trying to save algebra. Try to save algebra look good. If you love something, you don't want to make it look bad, right? You want to make it look good. You want to use it to solve the problem. You just cannot say, well, algebra is not strong enough to solve this problem. You don't want to say that because you love algebra. So you are trying now to save algebra. Okay, you are trying to save algebra. Now, what are you going to do? The first point is 1, and the second point is 1.22. And there is another secant line. However, this secant line is bigger than this secant line, right?
Yeah.
Does that make sense? This secant line velocity will be different, right? Okay, let's find this secant line velocity right here, so it would may make more sense. This secant line velocity is d2 minus d1, t2 minus t1. What is d2? D2 is 20 minus, very good, 13.33. T2 is very good, 1.22 minus 1. Oh, you gave me the difference. Okay, very good. Okay, 6 point what? I don't want to go there. 6.67 over 0.22. Help me with that one. 6.67.22. Help me with that one. 30. Okay, let's use the whole number. Okay, 30. So those people who said I was innocent, now they are not feeling good, right? Okay, because the algebra tells us that the probability of him breaking the law is higher because very close to T2, D2, he was moving 30 miles per hour. So if he was moving 30 miles per hour over here, him moving at least 25 miles per hour over here is higher. But I can always go to the code and say, well, no. Prove that I was moving more than 25 over here. Not right here, not right here. I don't care. Because I'm trying to kind of save my money okay? I don't care whatever I was doing over here. Show me I was doing it here. What do you do now? You say, well, I'm going to show you. Okay, sure. At 1.22, right? I'm going to do that graph again. So, what is that one? What is that one? 1.5. And this one? 30. So this, let's call this one 1.22 since we are interested of 1.22. At 1.22, what is it? 20. This one. Oh God, how much should it touch? Just once. Like that. By definition, this is a tangent line. It touches the circle how much? Just once. This is more visible than this one. Please understand that this touches just 1 point, and 1 point has how many value? 2 value. 1 point has how many values? 2 value. 1 xy 1.22, comma 20, comma not 20. 1.22, comma 20. Yes, very good. Trying to confuse you.
Don't do it. I'm already confused.
Okay. All right. Now we're gonna do that. Trying to make algebra look good.
You recording?
Yeah. Okay. Now what are we gonna do? We are trying to make algebra look good. Now we're gonna say velocity in instantaneous velocity because that's what it is. Because 1 point is what? D2 minus this is D2, right? This is D2, right? And this is also T2, D2. So D2 minus D2, T2 minus T2. 20 minus 20, 1.22 minus 1.22, 0 over 0. Try to save algebra, but you fail to save algebra. Because algebra take you nowhere. It took you to 0 over 0, and 0 over 0 is garbage. Okay, does that make sense? Because you are trying to find what is going on at T2, D2. At that 1 point. You don't have another point. Because
when you just have 1 point, when you use the formula, it's the same thing, but the same thing, just 0. And that's what algebra go to.
Breakdown, yes. Okay. Now algebra breakdown, we have to think outside the box, and someone taught it for us and gave us a great machine, and that is derivative. We're going to use that now. Okay, so I'm going to erase it. Can I erase it? Okay.
Professor, are you recording all of this?
Yes, because this million steps, and
at this point I stop writing.
Once you fall in love with calculus, then we'll start calculus. Okay. Okay, now we're gonna do what? We're gonna use that machine. We already show how to invent that machine, right? We're just gonna stand up and say that, and hopefully someone else than him. We're gonna. You wanna do it again?
Yeah.
Okay, stand up and say it.
You say f of x is the limit, and h approaching to 0. F x plus h squared minus h over h of fx over h.
Okay. Now,
Square. F plus fx plus h squared.
okay, that's fine. Okay, someone else tried. But he did a good job for tonight. I mean, we have lots of, yeah.
F of X.
No.
Wait.
F prime of X.
Who said that? Very good. Please stand up and say it.
Oh, whole thing?
Yeah, whole thing.
It's the limit of,
No?
no, it's F prime of X equals the limit as h approaches 0 of x minus h.
F of x plus h
Oh.
minus f of x over h.
Very good. Why only me?
What did I say wrong?
We don't want to clap our hand twice for one people.
No. What was the difference between that one and the one that I said?
But you said it's square. You said it's square.
Yeah, but one wasn't the. Yeah.
You said it's square. Okay, now I want one people to make it useful for this one.
So it's going to be when f prime of x a limit approaches 20. No.
Oh.
Okay.
Okay.
P prime t equal to limit when t approaches to 1.22.
Okay.
Delta t approaches to
The default is 0, but you can write 1.22. Doesn't matter. Okay.
I mean, 15.
Default is 0, but you can write 1.22. As if, because you just don't know it is 1.22 or what. Okay. All right. But you can write delta t goes to 0 or 1.22. It doesn't matter. You can call it 1.22. Okay. Then what? Yes.
40 over 3.
No, not yet.
f of t plus p of t plus minus p of t minus p of
Minus
t
over velocity.
Very good. Thumbs up. You did a good job. Yes, that's what it is. They are the same. Yes. They look different.
Yes.
Yes. Can you look different and still be same?
The triangle means velocity.
Can you look different and still be same?
Yes.
Can you look the thing you loved yesterday? I forgot. What did we wrote? 1 plus I forgot. But we did something that is equivalent to that, but not looking same. Right?
Yeah.
Okay. You remember that, right? Okay. So that's fine. So what are you going to do? Now, p prime of t is equal to limit delta t goes to 1.22, and then what are you going to do? We know our function, so let's write the function over here on the top. P of t is equal to what? 40 over 3 t squared. So we have to take the derivative of this one using the definition of limit. This is the definition of limit. This is the definition of limit. We are taking the derivative using the definition of limit. So, then what are you going to do? What is waiting to be replaced? T is waiting to be replaced. So 40 over 3 t plus delta t squared. And then what? Minus 40 over 3. Minus 40 over 3 what? T squared. Same idea. Over delta t. Delta t. Delta t in math, in physics, delta t. In math, h. But h is the default. Okay. What are you going to do now? This is algebra now. This is something you feel comfortable now. Limit as delta t goes to 0, 1.22, If I say 0, because I'm used to saying 0, because 0 is default. 40 over 3, a plus b squared. So help me out. T squared. T squared.
Plus 2t delta t.
Uh-huh.
Plus delta t squared.
Okay.
Minus
Over?
delta t.
Over what?
Delta t.
Why?
Why?
Why? Why you have to put a bracket? Anybody?
No, 2, 2.
Over 2.
Oh, nobody knows. Okay. Why I have to put a bracket? Because you have to multiply that. Very good. So p prime of t is equal to limit as delta t goes to 1.22. What happened over here? You distribute 40 over 3. 40 over 3, what? T squared plus 80 over 3 t delta t plus 40 over 3 delta t squared minus 40 over 3 t squared over delta t. Okay, I am saving my space, so I put it like that. Is it okay? All right.
Can you put the bracket to say that it's everything that is over there?
Yeah, sure. Like that? Okay. Now something cancel. 40 over 3t squared, 40 over 3t squared, cancel. That makes us happy, obviously, because we don't want to, that's what I want to know this. Limit as t goes to, delta t goes to 0. What is it now? What is the common factor?
T.
Not t.
Delta t.
Delta t. Delta t is the common factor. If you factor out delta t, what do you get? 80 over 3t plus 40 over 3 delta t over delta t. Remember I told you, you have to find the mechanism to cancel h on the bottom. You can find the mechanism to cancel the h on the bottom?
If you cancel the h on the bottom, you are a good track.
Yeah, you are on the good track, yes. So h on the bottom, h on the top, cancel.
That's why I was asking, so where did that 2 come from when you put it up there before? Because I didn't see that.
This too?
No, I didn't know you changed, and then you erased it and changed it to delta.
That was a mistake. I had no idea why I put 2.
Oh, okay.
Yeah, okay. That was not intentional, by the way. Sometimes I do intentionally. That was not intentional. Okay. So p of t, p prime of t is equal to what? Limit as delta t goes to 0. Okay, now I'm gonna have to write delta t goes to 0. Okay, 0. I'll explain in a second. Delta t. Now you will understand why it is. Okay. So I just put it there because you kind of saying it now. You'll understand why it has to be 0, because 0 is default, and you will see why. So limit as delta t goes to 0. Delta t goes to 0 and delta t goes to 1.22 is same thing. Can I say that?
Yes.
If there is no difference between 1.22 and 1.22, what is the distance between, what's your name? Riyazul. What is the distance between me and Riyazul? 1 meter. What is the distance between me and him? 0.5 meter. What is the distance between him and him? Nothing. 0. Does that make sense? Okay. Now 1.22 and 0, is it the same thing?
No. That wasn't me.
That was who? Is it same thing?
No. Yes,
You approaching to 1.22, right? If you approach 1.22 and you're very close to 1.22, you are 0.01 meter away from 1.22, then what is the distance? 0.1. If you are very close, 0.001. If you are even closer, 0.00001. If you are even closer, like me, touching the rear zone, then what?
0.
It's 0, right? Does that make sense?
Yes.
So can we accept that fact that when h approaches to 0, delta t approaches to 0, the secant line converges to tangent line? Does that make sense? This is crazy. Like, if I say 0 and 1.22 is same thing, and you share that information with your grandma, then your grandma will probably say, don't go to his class anymore. He doesn't know even the basic algebra. But this is true. Because this is different type of world. Does that make sense? Yes? Yes? No?
So when delta t approaches 1.2 and then 0, you're saying the same thing, but how
Is getting very...
It's so small. And
it's getting close to 1.2, I understand that, but
If he is sitting at a location which is 20, right? At a location which is 20 meter from me, right? Or 20 mile from me, right? He's sitting 20 mile from me, right? Okay, now how close I am from him? 10. Now how close I am? 5. Now how close I am? Very close. What about now?
1.
Now? 0, right? So then what can we say? What would be our conclusion? Very inside, this has to come to mind like that. It's not like
It's not logical.
this is not like you watching a movie and this has to come to very deep, deep inside our brain. It has to come to like that. Does that make sense? Yeah.
Yeah, delta t is the change in time, right?
Delta t is the change in time. Yes.
Yeah, so if we're getting to 1.22 and we're at 1.21999999, then the change, the delta t is going to be close to 0 because we're approaching it, we're very close to it. So if we're like at 1 and 2 and we're trying to get to 2, that's going to be like the change in time. So if we try to get closer, it's going to be a little 0, I think.
I think that helps a lot, right?
Mm-hmm.
Did you understand it now? Because he said it instead of me moving to him, then I can say he said that 1.22, 1.21, 1.21, 1.2. So this is what he was trying to say. Delta t goes to 1. Our target is 1.22. Delta t goes to 1.1. Delta t goes to 1.12. Delta t goes to 1.19. Delta t goes to 1.99999999999 and 9 forever. What does that mean? Delta t goes to 1.22. And what does that mean? Yes.
I think that if like you show like y2 minus y1, and then like in the bottom side of delta t, if you put it as like y2 minus y1, and you show that y2 equals 1.2,
that's right.
and y1 equals 1.9999, and you see that is almost 0.
That's right. This is almost 0, right? Is this almost 0? This one and this one is almost 0?
Yeah.
Okay. What is the difference between this one and this one? Can we say, without being very nitpicking, can we say this one and this one is almost same? This one and this one is same. For calculus, this one and this one is same. For anything in the universe, this one and this one is same. Does that make sense?
Professor,
not rounding. We are not talking about rounding. We are talking about approaching.
Right, that's what I said. The sticking point is not the value of the number as much as the proximity. The distance gets to a point where it reaches.
That's right. That's right.
The proximity, that's approaching.
That's approaching. It's never going to be 1.22. It's never. Because that's the calculus. The calculus is a process. It's never going to be at there. It's always a process there. How much closer you can get? As much closer as possible without touching. Okay. Okay. Does that make sense now? Okay. All right. So let's finish it. What is it now? 80 over 3 t plus 40 over 3 delta t. Delta t goes to 0. Right? Is it okay if we let delta t goes to 0 now after kind of explaining it a lot? Okay. So this is the last day of the semester. Okay? Because there is nothing much to do, because that's it. What is it? P of t?
P of t, 80 over 3.
Okay, good. You are not using limit anymore. Very good. 80 over 3.
80 over 3.
80 over 3t.
Substitute the t through 3 over 2.
3 over 2. Very good. Very good. 3 over, not 3 over 2. Why 3 over 2?
Because it's the length of the tangent
No,
between the problem.
3 over 2 is not point of interest. What is this? What do we have to plug in there? 3 over 3, not 3 over 2, 1.22. Okay? 1.22, right? Does that make sense?
Yeah, the time.
1.22. Now 80 over 3, 1.22. You already calculated it by calculator? 32. Okay. 32 mile per hour. Okay. Now, yes, I was moving at least 32 miles per hour. So what do you call that? Instantaneous velocity. Instantaneous velocity is what? What type of velocity we are talking about when you say instantaneous velocity? Is the slope of the tangent line. Is the slope of the tangent line. Is slope of the tangent line. That is instantaneous velocity. That is means if I drop a chalk, that means what is the velocity of chalk? If I ask you, someday I'll ask you, okay, I'm not going to drop some chalk, and I'm going to ask you, find the velocity of the chalk right here. And then you're going to find it. That is instantaneous velocity. Okay, by using calculus. So, yes, so we're going to now do the final thing, and I'll let you go. And that is, yeah.
Hey, before you erase that, can you make sure that the laptop catches that side?
Oh, I think so. Yeah, it's kind of too late because.
No, just turn it so it
Oh.
catches it. That's all.
Yeah.
Yeah, that's all.
Okay. Okay, so let me erase this. And then I'm going to write how the hypothesis, the biggest hypothesis of calculus 1, and that is when h goes to 0, the secant line, the slope of secant line converts to slope of tangent line. So the slope of secant line, this was the slope of secant line, scenario 1. This was the slope of secant line, scenario 2. Are you familiar with this scenario? Okay. This one was, there are 2 points, 0, 0, and 3 over 2, 30, right? 2 points, right? This one, 2 point, 2 point, 2 point, 1.22, 20, and 13.33. Very good. Then last scenario, without like, there can be many scenario. Yeah, it can be other one. And the last one was, I'm gonna make it. So what is this point? 1.22, comma? No, 20. And what is the slope of this one? 32. What is the slope of this one? No. 30. Who said 30? 30. What is the slope of this one? 20. Yeah. If h approaches 0, is h approaching 0? Meaning you going closer to the interest point. And 1.22 is as h approaches to 0, the secant line converts to tangent line. Okay, can someone stand and say that as h approaches to 0, the slope of secant line converts to slope of tangent line? Who want to say that? That would be last line of our night. Who want to say that?
Which stand up to say as h approaches 0, the slope of the secant line turns into the slope of the tangent line?
Yes.
As h approaches 0, the slope of the secant line transforms into the slope of the tangent line. It turns into the slope of the tangent line.
What's your name?
Jeff.
Jeff. A big round of applause for Jeff. Don't forget to look at the sky tonight. Good night.
Professor, the sky on your computer.
Oh, okay. No, I mean the moon is